Here we need to solve a problem involving reciprocal trig functions. We've got to show that the left hand side here is equivalent to the right hand side. In general, with these kind of proof type questions, you need to pick a side to start with, either the left hand side or the right hand side, then do some simplifying, and you should end up with the other side. As a general rule, I would always start with the left hand side unless there's a very good reason not to. So in this question, I would start with the left hand side, write it down. So cos x 1 minus sine x plus 1 minus sine x over cos x. Now, I wouldn't write down the right hand side. I wouldn't write that equals the right hand side, but I'd write down the right hand side maybe down at the bottom here, because that's where you need to end up. So you need to end up with 2 sec x at the end of your proof. Now, first step here, it isn't obvious what to do because there are no reciprocal trig functions on the left hand side. There also isn't a tan, so you can't change that to sine over cos. So it's not obvious what to do. But if you look at the right hand side, it's a simple, it's just one single expression. It's not two fractions added together. So a sensible plan is to get a common denominator here. And this is often what you need to do for these kind of questions, is to write them as a single fraction, because you end up with just a single expression. So let's try to write this as a single fraction. So if we get a common denominator, if a common denominator would, if we multiply the two denominators together, a common denominator would be this, and then we multiplied this by cos x, so we also need to multiply that by cos x, so that would give us a cos squared x up the top here. Now on the other side, we've multiplied this by 1 minus sine x, so we need to multiply this by 1 minus sine x, so that would be 1 minus sine x all squared. I think we need to simplify the numerator now by expanding those brackets. Remember this here, you need double brackets when you're expanding this. So you want to do 1 minus sine x times by 1 minus sine x, which would give us 1 minus 2 sine x plus sine squared x. And all of that is still over the same denominator, which is 1 minus sine x cos x. And now you can remember that cos squared plus sine squared equals 1. So we will be able to write this as, so 1 plus this one here will give us 2. So we get 2 minus 2 sine x for our numerator, and then we've still got the same denominator. So our denominator is still 1 minus sine x times by cos x. Now, run out of space here, but you can factorize the numerator now to 2 times by 1 minus sine x, and this is the good bit in these kind of proofs, the bit where you realize that you know what to do now. You can tell you're going to get the answer, which is always a nice feeling, especially if you're in an exam, because those are going to cancel. That's going to leave you with 2 over cos x, and then obviously 2 over cos x is equal to 2 sec x. which is the right hand side. So we've gone from the left hand side, done some simplifying, used the identity cos squared plus sine squared equals 1, and ended up with the right hand side. So now we have to do part B, where we use part A to solve this. In part B, we need to use the answer to part A, so we just replace everything on the left hand side here with 2 sec x. Even if it didn't say hence, you should always be on the lookout for using the previous part of the question to help you out with parts B or C. So we've got 2 sec x equals minus 2 root 2 here. These 2's are going to cancel, divide both sides by 2, and we've just got sec x equals minus root 2. So now there is no sec button on your calculator. You can't do inverse sec on your calculator. So you need to just change that to cos. So that's 1 over cos x equals minus root 2, and then do the reciprocal of both sides. So cos x equals minus 1 over root 2. You don't really need to write this step. You can just go straight from sec x to cos x and do the reciprocal. So if cos x equals minus 1 over root 2, this is just what you're used to doing. In the first year trigonometry, where you just do inverse cos on your calculator. If you do that, you'll get the principal value for x. And remember, you're in radians here, so make sure your calculator's in radians. Your first value should be 3 pi over 4. And then I like to use the cast diagram, but it's up to you how you do these kind of questions. So I would do it like this, and then 3 pi over 4 is going to be, it's going to be over in this quadrant here, because this is pi over 2, this is pi, this is 3 pi over 2, this is 0 or 2 pi. So we've got cos is negative here, cos is negative, so it's going to be in this quadrant and this quadrant, and so we can reflect the line down here, and this angle here is going to be 3 pi over 4, which means so is this 3 pi over 4, and you could write this in, that would be pi over 4, and that'd be pi over 4. So if we just write down our angles as we go round, this is 3 pi over 4, already got that one. We carry on going round, that angle there would be 5 pi over 4, and then if you keep going round again, another 2 pi, so you can go all the way around again. That's looking a bit of a mess, so let's get rid of that last one. But basically you're just adding on 2 pi to this, and that's going to give you 11 pi over 4. And then if you add 2 pi to this, that's going to give you 13 pi over 4, which is the answer to part B. You should now be able to have a go at some of the questions from exercise 6C. This kind of question that we've just done here is like question 4. In fact, I think this is question 4E. Part A was question 4E. But there's lots of good questions in this exercise, so make sure you do plenty of these questions, including the harder ones, questions 8, 9, 10 and 11. But like I said, question 4 is very good practice for these kind of questions that we did in part A.